Here's a video on setting up a processing pipeline for the two data sets that you acquired with Lloyd. Let me go. By the way, I'm going to be using EMSE version 5.6.1. And let me look in a folder here. Okay, so what I've done, I have a folder. Oh, by the way, there's a zip file here that I'll provide, which is basically the initial state of this folder. This other folder I'm showing here, I already went through it once, and so that's essentially where we're going to be going. But this zip file is the same as this file that I'm starting with. Okay, so I put the two BDF files that you and Lloyd recorded, and I just named them a little bit differently. Just as you'll see, we'll be using some scripts, and in the scripts we'll be using subject or participant IDs and experiment IDs. So I just gave them this name. The other thing I did with it is I took the configuration file that you gave me, and the one that you want to be using going forward, and I changed the channel names in these files to match with the configuration that you're planning to use going forward. So this is our input in this folder called BDF. I'll show you in a bit what's in this proto folder. I'll show you right now what the contents are, and then we'll see in the workspace. We have a Biosemi 64 ELP file. That's the what EMSE calls a probe. This has the electrode positions in it. There's a file called proto.bdf. Now that happens to be just one of these two BDF files that I renamed. It's going to serve as a prototype, and we're not really going to analyze it per se, but we're going to use it as a prototype. And as you'll see, this file in particular, the ppm, it has a filter pipeline in it. I'll show you that. And it has display preferences, and so these will carry over. There's a workspace here, which I'm going to load momentarily, and then there are three scripts. These three scripts, I will show you what they do, but just briefly, the first one is going to take the raw data from the BDF. It's going to apply the filter pipeline, and it's going to save the result to a new file, which importantly the digital AIR filter will be applied to the whole data set, so that any filter warm-up artifacts will be out at the edges, and otherwise the filter will be continuously applied throughout the whole data set. Then following that, I want to show you, this is relatively new, but it's been used in another lab with success with a lot of participants. So it's, I think it's ready to try, and I'll show you how it works with your data. This script will automatically mark blinks and clean segments, and then we will apply the ocular correction, inspect it to make sure that it looks reasonable, and then once we do that, we'll follow with this other script, which will automatically mark the horizontal EEG following the correction. Sometimes the horizontal EEG is sort of buried in the middle of the vertical artifacts, blink and vertical artifacts, which tend to be larger. So after we've corrected the blinks, the horizontals stand out more, and we correct that in a second pass. Finally, after all that is set up, we'll set up an event, what's called an event pipeline, and this will do the averaging. And okay, let's get going here. So I will I just did help about just to show you that I'm using EMSE version 5.6.1. And let's go and open that workspace, which is in the folder. Here it is. And okay, so our workspace has 2 projects in it so far. The first one is called Proto, and this Proto points to the prototype data that I was showing a bit earlier. So it's pointing to this Proto BDF file, which, just to reiterate, it's just a renamed BDF file from one of your examples. It just serves as a prototype. So let me just load it here. I'm going to double click on it. Nikki, I think this is yours because you had more prominent blinks in your data than Lloyd had. So so obviously it's not blink corrected, but let's see. It does have filters in the pipeline. And I mirrored the settings that you and Lloyd used previously. So of note, this probe here, the Biosemi 64, is integrated in the pipeline. So if I highlight this one is already incorporated into the pipeline. If I say properties for it, we'll see the probe. So for example, you can see Cartesian coordinates here. These coordinates are based on the locations on the Montreal Neurological Average MRI head surface. So those are standard locations. That's integrated into the pipeline. Now we come down here. So these that are grayed out are part of the history of the processing pipeline. As a general rule, we don't change anything there, but it's there to remind us of the history of of what was previously processed in the data. These 3 right now are showing dark, and we can turn them on and off right now. So they're being applied live. The digital reference, I want to see, I'll click on properties. Oh, by the way, let me cancel here. There is one thing I did. You'll notice, and this is incorporated in the pipeline. If I go to Edit Channels, we'll see that I turned off the EXG7 and EXG8 channels. They were flat, didn't have any data, so I just turned them off. And that's part of the pipeline. Okay, let's go back. I'm just clicking on this blue triangle, which is a shortcut to the pipeline. Just to review what we've put in here, I know you know how to do this part. Just highlighting ear 1 and ear 2 to get a digital linked ears reference. And you'll notice here that because I changed the channel names of your BDF files, this is now as if the data had been recorded using your new configuration file. Okay, so we're just reviewing what the filters that are in the pipeline, the digital IR. I put a comment here. When you add the filter to the pipeline, you have an option of adding text if you want as further description. But the real description is in the properties, and we're applying it to all the channels. And finally, I added, this is for the sake of anticipating the horizontal EOG correction in the third script. We'll see how this is. But this, we still have our LO1 and LO2 channels individually. And it turns out we don't really need to make a bipolar channel to do blink correction. On the other hand, the horizontal, it is very helpful to have a bipolar for the horizontals, as we'll see. So basically, it's deriving this channel now that's showing up on the top. Okay. So this is the prototype. So if you want to change the filter settings or add other filters or anything in the pipeline, you can change it here in the proto, and then the scripts will use this pipeline, as we'll see in a bit. The other thing about this is you'll notice you can set some certain default display preferences. So EMSE automatically saves a preference file. If we go back to the proto, it's this one. And this preference file remembers our display preferences. So if you want it to be chart recorder mode, if you want to set a certain scaling here instead of auto scale, you can set something. I set it to 200. You could set it to something else, 100. This is the number of seconds per page and so forth, where you want to start. And the other thing, notably, I changed the color of the display color of the LO1, LO2, IO1, and IO2 channels, and I did that using this View, Display Options, Channel, and I went down here and I just double-clicked on these, and you have the option to change the color. These display preferences, the scripts will copy those over, as we'll see. So let's okay, so I don't really need this prototype for the script, but let's I think you get the idea that the prototype is where you set the filters settings that you want to carry forward. Okay, I also made a completely empty, well, except I made a folder called Grand. I put a probe in it. This is in anticipation of making grand averages. The reason I put it in at the beginning is that in anticipation of making averages for the individual participants, they will typically, you'll be adding them one at a time as the participants come in, and then you want to update the grand average. And so I put the grand average at the beginning because you'll be adding individuals sequentially to the workspace, and otherwise, so this makes the grand average at the beginning of the workspace. Okay, so let's run the first script, and let's see what it does first, and then I'll briefly show you the script itself. So I'm going to say batch run script. It's fine. So I've got this one, and I put 01, 02, 03 just at the beginning, so they'll show up in the intended sequence of applying them. So the intent of this first script is to take the raw data, the BDF file, apply that pipeline to it for each individual, save that into a directory structure, which we'll see, sorting them out participant by participant, and putting that in the workspace. So it's just kind of setting it up. So I'm just going to double click on this, and we'll give it a little time. If you see this, it says not responding. That's just because EMSE is working away. So it's applying, but basically it's applying the filters, and in particular the digital IR filter, to the entire data set with any warm-ups at the very ends of the data, and then it's saving this to a new file, which we'll see. And it's going to do that to both. So we're in a loop where we're doing this with both data sets, yours, Nikki, and also Lloyd's data set. So now it's doing the same thing to Lloyd's data set. We'll see the result in a bit. Okay, so you'll see now the workspace now has two new projects. One, I don't know how you want to number your participants, but I just sort of arbitrarily called this S001. I think that's you, Nikki, and S002 should be Lloyd's. And you'll notice this little asterisk here, which means that the script added these two projects to the workspace, but that workspace hasn't been saved. So I'm just going to File, Save Workspace. Okay, now it's been saved to the workspace file. Let's look in these. So S001, we now have a binary file. Let's just double click on that. Okay. It happens to look a lot like the prototype because it actually is, Nikki, this is your prototype. Difference being here, let's click on the shortcut to the event pipeline. Notice everything is now grayed out. So everything is now history. Everything here has been applied, which means it has the advantage now that, for one thing, the analysis will go faster. But in particular, this digital IIR has been applied to the entire data set. So you don't need to worry about warm-up artifacts or anything. All right, and the same thing for subject 2, which happens to be Lloyd's data. So I'll just double click on that one. Okay, so Lloyd doesn't have as many blinks in his data, but you'll notice all the same filters have been applied to Lloyd's, and the display preferences carried over, as noted by the channels colors here. If we wanted now to change the display preference for Lloyd's data, we can do it here, and it'll stick for Lloyd's data if we want his display preference to be now different. If I unload this and reload it, the display preference is now specific to Lloyd's data. All right, so where do we go to here? I just want to mention that in principle we could blast right ahead and go right to this next script, which is the let's go back here, the AutoMark blink script. Oh, also, I didn't really show you the script itself yet, did I? Let me just give you a peek inside of it. I think this is something we can go over in more detail, let's say in a Zoom session. But let's go to this one. Okay, so briefly, these scripts in EMSE use an XML type format so that you can nest different things. And so up at the top we have what are called string variables. So there's a string variable SID for our two subject IDs, S001, S002. Then we have a condition ID, which would be for your experiment, your visual P300. But for the same participants, you might be running different experiments. So you could certainly add different experiments or condition IDs as well. So this part at the top can be used for looping over participant, experiment, and other variables. And then this part down here is a script that is looped over by these variables. So, and it's a sequence of commands. So there's something called an assert command. This assert command enables us, for example, let's say if I add a subject 003 here, the assert command basically says if the BDF file for subject 003 isn't there, skip over it. So in other words, we could plan ahead with our subjects and put that in the script if you want, and the script will just skip over anything that's not in the BDF folder. On the other hand, once you've already analyzed something, let's say you now add subject 003, and you've already analyzed 1 and 2, and you don't want to reanalyze 002, this other assertion says if the output result already exists, if the output has already been created, then exit the script and continue. So the one says skip over anything if it's not there in the input, and the other says skip over it if it's already there in the output. Okay, so that enables you to use the same script when you're adding new participants without redoing everything. And there are other commands here. I think we can go over these in more detail. But notice that mostly, for the most part, these identifiers, the SID and the condition ID, these are provided at the top, and then this is just the format of the file name that will get created. And as you'll see, let's go back here. Notice that we ran this script and it created this folder called out0. The reason for the 0 is sometimes you might want to do things in multiple stages, and you might have an out1 or even an out2. But this is like the first stage of output. And under that, we have subject folders. The reason for separating things out into subject folders is if everyone goes in the same folder to begin with, as the analysis proceeds, more and more files get generated, and pretty soon it gets really hard to disentangle all the results. So the script is creating a folder for that. Also, in anticipation of possible other experiments for the same subject, there's a folder for the condition or experiment ID. Then in there we'll see the results. So the main thing is this binary file was created. So you can see this is the big file that has the data in it. But there's a separate header which describes what's in there. The events came from the original BDF file. The filter pipeline is in there. the preferences are there, and just a backup for the filter pipeline. Okay, so you don't really need to worry about that too much. But the we ran the script, and that was generated. Now, if for some reason we want to rerun everything, all we have to do is delete this output folder or give it a new name and rerun this script, and everything will be regenerated. Okay, but let's look at the next phase, because now what I want to do is show you that we can do a pretty good job of automatically marking blinks, or what we might call good blinks, and clean data for the ocular correction. And so this makes it more objective than going through the data and marking them. So let's show how that works. We don't need these to be loaded, so I'm going to unload them. And let's just go again, batch run script. This time I'm going to do the step 2, which says automark blink. Okay, let's just run that one. I don't think it takes very long to run. Okay, it's done. Okay, it hasn't. Okay, what it's done is let's look at it and see what it's done. So let's look here. So we'll see that certain marks have been added. So this segment is marked as a clean segment. You can see down here that the ocular channels are fairly flat. We can see that a couple blinks here were marked, but not all the blinks were marked because we set certain criteria, and we can proceed through the data. Lots of blinks to choose from in your data, Nikki. So, but the criteria we set, we can review that and see why are some of these selected and others aren't. But the other way to look at this is we can go to Edit Events, Edit Event List, and by default everything is in sequential order. But if I click on the name and say a second time, then it's sorted alphabetically by event name. You might be okay. So clearly, we've put in here these clean segments. Let's jump to one somewhere in the middle. So these clean segments were identified here, and quite a few were identified, and it was done using some objective criteria. So we've got plenty of clean data to work with. Also, even though we were kind of picky in those blinks, notice we're only picking some of your blinks, we still have plenty of blinks to choose from. As you can see down there, we've selected a lot of them. And if you look at all of them, it's pretty clear that they're all blinks, even though we haven't selected all of them. This one here, for example, one of the criteria is that we're not going to have another blink. We're not going to select this blink because this other one is overlapping. But there are other reasons why these other blinks weren't selected, which has to do with criteria of artifacts on other channels, basically. And those things can be tweaked, but I'll show you how this one works. The other thing that you might be wondering about is a couple new these events called gap. This is optional, but I put it in there. A gap a gap is defined, let's see, in the script. Let's see where we put that. This command here called insert segment in gaps. Okay, so we specified, we said if there's a period of 20 seconds or more between events in your experiment, then 75% of that interval is going to be automatically marked as a rejected interval. And you can see that that's usually a pretty good rule of thumb, unless you're doing ongoing EEG, where this wouldn't be appropriate. But in an event-related experiment, notice here it automatically marked this big gap between events, and you can see it looks like, you know, there was a pause of some sort there, and there's a lot of ocular activity. So that was automatically marked in this case. Here we see an event 202. If we go preceding, we see there was an event 14 here. So 75% of that interval between the 14 and the 202 was marked as reject. Okay. Let's unload that, and let's oh, I'm sorry. We want it loaded. Let's go ahead now and do the ocular correction, because really the hard part's been done. So what we really want to do now is add an ocular artifact correction filter, this one. I'll just say dash blink. We're going to correct blinks first. And we're going to get all the information from the existing data. So we'll just say next here. The artifact segment is called a blink, so we'll highlight that, say next. The clean segments are also in the same data. I'll select that one. Next. And I'll say next. Okay, so we have a clear discrimination. We have clearly one component and possibly another one. If we put a, you know, this a scree plot here, we have a sort of an imaginary straight line going like this. This one is clearly, we have one component that's popping out. And this second one might also be, I think, one thing to notice, I think, as I recall, you and Lloyd, that because Lloyd was demonstrating this, and Nikki, you were the participant, but I think you were also looking at the data. So I think your eyes weren't looking straight ahead, perhaps. I don't know. But we do see this correlation in the lateral eye channels that are correlated with blinks for whatever reason. So I could say either one or two. I could make a case for either. Let me just do two. I'll say finish. Okay. And now the blink correction has been applied. So we can see this particular blink has been corrected. Let's go through the data and look at some others here. There's a blink. These are the ones that were marked. Of course, not all blinks were marked, and of course we want the blinks that weren't marked to be also corrected. So let's let me cancel this. Let's just see if there are other unmarked blinks in this window. So I'll uncheck this. So this one is not grayed out, so it's live, and we can uncheck it. Ah, yes, indeed. So these two blinks were marked, and they were used for training the ocular correction, but all these other blinks here, 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 these were also corrected. So I do believe the ocular correction is performing well for the blinks. And our we did not set these channels to pass through. That's kind of another philosophy, although this LO1, LO2 channel is a pass-through channel. It always is because it's bipolar. But these channels were not, so they're also being corrected. We know their location, so you might actually want to use them for mapping. Okay, let's see what happened to Lloyd's data. So let's go here, and the setting that I changed is there. We've got lots of clean data. It looks like Lloyd was hardly blinking. But let's see if we captured any blinks. Okay, we got a lot of clean data. We can see some of it here. And the criteria, I'll show you briefly the script so you can see what it is. Oh, we got a few blinks. Hardly any, though. Only 4 blinks. Let's go to those and see what they are. Okay, there's one. Let's see, blink number 2. There's another one. We got kind of the beginning edge here. Blink 3. We got one there. And blink 4. Yeah, so there, like before, there could be other blinks, like this one is a blink, but it wasn't selected because of other criteria. So in this case, with a participant like Lloyd, who's not blinking very much, you may decide not to do ocular correction and just do rejection. Or you may decide to do correction. Of course, you have to have at least a few blinks in order to do any form of correction. Let's go ahead and do correction here. I think it's debatable whether we need to do that, but I'll go ahead and do it. And just like we did before, I can say next here. I can say blink is the artifact segment, clean, and next. Okay, now the scree plot for Lloyd is a little more, looks different. Well, first of all, we don't, all of these, this is an effect of not having as many blinks to choose from. So, and we're not seeing the tail end of this one, but we might have up to 1, 2, 3, 4. But there's this is definitely an edge case. I might just choose, in this case, not to do ocular correction. It's not clear how many components we should select because we only had a few blinks to begin with. But let me pick 1, 2, 3, 4. Let's pick 4. We can turn it off. But let's just see how it behaved. I mean, it did correct these blinks. And let's see, was that in the vicinity of something? Yes, it also corrected this one that wasn't marked. So it seems to be doing an okay job. Nevertheless, you might just decide not to correct it, which in this case we could just leave this unchecked and just do rejection, since the participant was very compliant. Or not. It's up to you. Considering that there may have been other blinks out there that weren't marked, and it seems to be doing okay, I will leave it checked. Okay, now that we've corrected the blinks, and I'll show you briefly the script, and this is tweakable. So this script number 2 that we just ran. Oh, by the way, I'm using Notepad++, which is nice. It's nice for looking at XML files. I'm using this language XML, and since the scripts have XML extension, it automatically recognizes those. So it does this nice, for example, if I highlight this AutoMark command, it's just everything in here is related to this AutoMark command. And these are the parameters. And I'm not going to go into all of this, but these are the criteria I set for selecting blinks, and there's some flexibility in here, but these are close to the parameters that have been working well for another lab. And we also had some other criteria that we, for example, on the LO1, LO2 bipolar channel that we derived, has to be between 2 bounds. Between plus or minus 50 microvolts, we set it to be, in order to be considered a quote-unquote good blink. Okay, and then in the same script we also auto-marked the clean. So this is where we got the clean data. We can go over this in more detail as needed. And let's look ahead now to the HOG, because it's also using the AutoMark command with an HOG type. And this time we're going to be looking on the bipolar channel that we derived, LO1, LO2. We're going to be looking for thresholds. This is e to minus 6 makes it microvolts, so this would be 125 microvolts. We're going to be looking for opposite polarity on FT7 and FT8 to make sure that it's a bona fide horizontal eye movement, because the polarity has to be opposite. But it doesn't matter whether it's positive left or positive right. Either way will be counted as an ocular horizontal movement. Okay, let's try that and see what happens. So let's go batch, run script, AutoMark HOG. Okay, so let's look at your data, Nikki. And now the goal here is to mark HOG. So let's go events, edit event list, and there's one that was found here. Let's select that and say go to. Okay, so again, we're being a little bit picky here. So obviously there's horizontal artifact going, which we can see on the bipolar, lateral bipolar channel. But it selected just this one. Importantly, we did the blink correction first, and then the horizontal is easier to discern. Let's sort on name a couple times, and now we can see, yeah, we did find a number of HEOG segments. Let's go through those. And clearly there is a lot of horizontal eye activity. Probably, I'm guessing, Nikki, you might have been looking back and forth to display, maybe, because it was the first recording with whatever. There's quite a bit of horizontal eye activity here. Once again, we're not selecting all of them, but we can see, yeah, we selected this one, and you can see the artifact in the EEG channels. Let's go to another one. Here we go. So here's a couple more examples. This is pretty clear. So let's do the ocular correction on these now. So I'll go to the filter pipeline shortcut. This time I'll add an ocular correction, but this time I'll call it -HEOG. And I'll say next. This time the artifact segments are labeled HOG. The clean segments are already marked, so I'm going to use the same ones that we used for blink correction. We'll say next. Looking at this plot, these might be a little iffy, but we clearly have one component at least. Let's do just one. We might want to do up to 3. These two might get some subtle aspects, but let's see what happens with just one. One should be doing the lion's share of the work. And so indeed it looks like it did a pretty good job here. So let's uncheck it. This one to see what it was like before. That's before and after. Notice we're correcting the channels down below. We're not correcting the LO1, LO2 channel because it's considered what's called a pass-through channel. It doesn't have a location. It's bipolar, so it's not a single location. So it's a pass-through channel. We do see, yeah, these other channels are being corrected, but maybe there's something remaining here. If we, I'm not sure if I change the number of components from 1 to say 3, if any of the subtle differences will be changed or not. Perhaps a little bit. It's really pretty subtle, and you may or may not want to include those extra artifact components. Essentially, it's like removing a channel. Essentially, we're removing one dimension of the 64 channel space whenever we remove an artifact component. So let's see how it did in the rest of the data set. Let's see, name, HOG, let's go somewhere. Okay, you can see it's helpful in a way that the bipolar channel was not corrected, because we can see all places where there was horizontal activity, even though it wasn't marked for training the algorithm. And if we uncheck here, I didn't mean to uncheck the blink. We can see here that here, over where it was not marked, we do see the effects of horizontal artifacts there. So, there we have our blink correction and our HOG correction based on these auto-marked segments. Okay, now if we look at Lloyd's data, I don't think we found any horizontal eye movements, so I'm going to go Edit Events just to double check. Let's see, name. We've got a lot of clean data. There's our blinks, but no HOG. So no point in correcting something in Lloyd's data. We'll just leave it as it is. All right. Let me stop here because next in line I want to show you the batch event pipeline.